hear me now? I hope you can hear me. Can we hear me? Can we hear me? You guys hear me? Can you guys hear me? Can anybody hear me? Can you guys hear me now? Anybody hear me now? All right. Um, please, guys, confirm if you can hear me now. Very good. So can you guys hear me now? Can you hear me now? Let me know if you can hear me now. Okay, that means you can hear me already. All right, so I had to restart my laptop to to get us back. Sorry about the whole hassle. All right, so let's just get started immediately. Okay, let me start by sharing my screen. Oh, we've been using window. All right, why is this still loading? Okay. Um, supposed to start with. All right, so guys, how was the weekend now? How was our weekend? Hope we interested. Did we did we do more research? Let me pull this here, see if I can get it better. Mine was full of work. Oh. It was a. All right, can we hear me now? Can we hear me now? I believe you should be able to hear me now. All right, I can continue, right? Okay, so I was saying that the inverter, all right, is that component that helps you. Loud and clear. Thank you. Is that component that helps you convert your DC from the panel to AC, right? And um, most of the appliances that we use in the right, they are AC appliances. What that means is that they make use of alternating currents, all right? The energy from the solar panel and the battery are direct current, right? They can't directly work with AC systems. Right? You can't plug, for instance, you can't go and plug your ACT battery and expect it to work. It will work. So you need the inverter to help you convert that DC right to AC. I'll show us an illustration just to help us understand that properly. All right, how that's all right. Thank you guys. So let me just clean this all off. So I was saying that the inverter, all right, does the job of converting your DC, all right, to AC. Your solar panel cannot work directly with your appliance. It can't work directly with your cooker. Neither can it work directly with whatever home appliances that you have, all right. So what you get from your solar panel and battery is a kind of a direct DC, all right? And this kind of signal cannot work with your appliances. This is what works with appliances, all right? This kind of alternating signal, all right? So what the inverter does is to convert, right? Convert this, all right, to this. That's what the inverter does. That's the primary job of the inverter to convert the direct current to what? To alternating current. Simple as that. Whether you now use it as a charger or whatever feature that it has, all those ones are secondary. The primary job of an inverter is to convert what? The DC, all right, that's direct current to what? AC to alternating current. Simple as ABC. All right. So let's move on. All right. So DC power from battery or panels to AC, which is used for household appliances and all of that and all that. So now efficiency is the ratio of AC output to DC input, indicating performance efficiency occurs as 30% to 50% of load. Now, if you have, for instance, can't draw it with this stuff. All right. If you have, um, let me, for instance, how can I remove this off? Just hold on for me. Let me try and manage my space properly. All right. So if you have an inverter, for instance, say you have an inverter here, all right? You have an inverter here, and let's say it's a 4 kVA, for instance, a 4 kVA inverter. Now, that inverter is expected to deliver to you some amount of power, all right? Now, when you see 4 kVA, you don't expect that, it means that the inverter can give you 4 kVA and so on and so forth, right? It simply means that both the power or the energy that the inverter itself requires to work, plus the energy that is going to give you, all right, is called 4 kVA, all right? And the ratio at which the ratio of the input, I mean the output to the input, all right, is what we call the efficiency of the inverter. What that simply means is that whenever you supply an input power from the battery or the panel to the inverter, and you get exactly the same output power from the inverter, it means that that inverter is 100% efficient. This is what I mean. So let's say again you have a 4 kVA inverter, all right, and you supply an input of about 2 kilowatts, right? It is expected that you get an output of what? 2 kilowatts, ideally. All right, ideally. This doesn't happen in any system. Okay. So what this means is that this inverter, all right, this inverter is 100% efficient, which means the conversion ratio of the inverter is 100%. Okay. But inverters, like any other machines, are not 100% efficient. Right? There are a lot of factors that will not make your inverter to be 100% efficient. But one, we'll talk about that once we start discussing about loads. All right. Your inverter is mostly an inductive, right? Because of the function of the inductors or the transformers that are inside the inverter makes it more of an inductive load, right? An inductive load have reactive power. Those reactive power are they are counter power, all right? Which will not make it to have, you know, the full power that is supplied to the inverter at the output. All right. We're going to talk about that later on our work. Just for you to understand that the inverter, right, cannot be 100% efficient. Okay. So you get maximum output from your inverter if you don't load it beyond 30 to 50% of its capacity, right? If you don't load it beyond 30 to 50% of capacity, you're going to get maximum power. By the time you get to load it up to 70, 80%, you are working the inverter so much that even the inverter itself might not function properly as that load. Even though there are inverters that can handle even up 80% load on them, and they're still going to perform efficiently. I'm going to check the reason why that is later in the course. And all. So let's just quickly move on and finish this. Uh, So now there are different types of inverters, and you can classify them based on you know um, based on the type of the application. All right, there are different type of inverter. All right, yeah, based on their application, you could have the commercial inverter, you could have the residential inverter, you have industrial inverter, you could have grid which are grid tie inverter, right, and so on, right, depending on your application. All right, but the type of inverter that we use mostly are the residential inverters, right? Which are pretty much available in the market. Those are uh, hybrid inverters or standalone inverters. All right, the hybrid inverter, standalone inverter. Those are the ones that we use. Even in some commercial application, you still use hybrid or standalone inverters. So what do I mean by standalone inverter? Standalone inverter is that kind of inverter that you need to it before it works. Okay, you have to connect the battery to it before it works. Okay, and also, right, which in this case also is the battery. It requires a backup for it to work. Right, there are inverters that can work without battery. Okay, but for standalone inverters, they need that battery backup for them to be able to work. All right, you can decide to now connect panel to them or not. Okay, but I mean to the battery so that in order for you to charge it. Right? But standalone inverters are just kind of inverter that requires you to connect battery to them. We also have what we call hybrid inverters. Right, hybrid inverters are we also use them in residential or commercial application. Right, are the inverters that have you know, yeah, you connect battery to them. They also work with battery backup. They need battery backup, but they also come with inbuilt charge controller. All right. I already told us about charge controllers already. How that is what is used to regulate, right? And maintain the voltage, the charging voltage of the battery, charging current also. Right. And some inverters come with charge controller inbuilt into them, right? Which means that you don't need to go buy extra charge controllers before you go to use them. So you can just run your panels directly, right? Directly. The board is now okay. Okay now. So you can run your panel directly into the inverter, all right? And it's going to be charging your battery at the same time. Okay. So those are hybrid inverters. All right. We also have what we call grid tie inverters. Let me write them as I'm even saying them. We also have what we call grid tie inverters. Okay. We have the grid tie inverter. All right. So we have the grid tie inverter, and the grid tie inverter is what is used in some advanced country and most of the time in mini grid systems, all right? So you have the first I say you have the standalone inverter. I talked about the hybrid inverter, and then now I'm talking about the grid tie, right? Is it Y or high? I don't even know. I think is that all right? Grid tie inverter. All right. So the grid tie inverter is that kind of inverter that when you connect it to your system, you have to tie it to the grid. What do we mean by the grid? Public supply, like the NEPA light. You have to tie it back there, right? Which means that you're not only going to be the one using it, you are also supplying power back to the program when you use it 3 times. Because just like if you decide to generate, let's say you create a mini plant, power plant, it's expected that you send some part of what you're generating, all right, back to the grid, all right. So the same way we have some inverters that once you use them, you have to connect back to the grid, right? That way, you'll be sending excess power that is available to you. You're going to be sending it to the grid, all right. So somebody that is connected to the grid, you can now use the power. So in advanced countries, right, government paid them for this. Right? Once you install solar system and you have a greater inverter and you connect to the grid, right? They're going to be paying you by how much you generate for them. All right. So government pay, people who do this in advanced countries. Yeah, only if you're trying to build a mini station, right? then it is expected that you tie back to the grid. I'm not sure you're going to be getting any money from there. Right? Na Nigeria we dey, you understand? Okay, so yeah, we have greater inverter and all of that. So this the greater inverter is usually for large application. If you're building, for instance, a 500 kilowatts, system, a 1 megawatt system, and so on. All right. So those are the types of inverter based on the application. Right. We also have inverter based on the output waveform. Right. We have inverters based on output waveform. Right. So considering inverter classification. Right. We also have inverter classification based on the waveform. All right. So you have the square wave. You also have the modified square wave, all right. And then you have, lastly, the sine wave, right? The sine wave. You have the sine wave, all right. So in this application, so for instance, in the square wave, all right, when you use your oscilloscope is that device that measures the signal of an electronic parameter. It displays. Let me show you what an oscilloscope looks like. So it's a measuring instrument that shows you the signal of electronic parameters. So it displays it to you, the type of signal that your is shows. So these are an example of an oscilloscope, right? So you can see what is displayed on the image is a wave is a sinusoidal wave, right? You can see it's a sinusoidal wave. All right. So this is like an oscilloscope, right? So what I'm trying to say is that when you have inverters that have square wave as their output, which means that when you check their output waveform, you are going to see something like this. Sorry about that. All right, you're going to see something like this at the output. Okay. This is how the output, the voltage that is coming out from the inverter, this is how it looks like. This is the way it's moving. All right. This is the exact way it's moving. All right. So this is the most simplest you can have. All right. Somebody said I can't hear anything again. What about now? I think I stopped at the square wave thing because that's what I was now. Can you guys hear me now? Can you guys hear me now? Can you hear me now? What's wrong? Can you see me? I think it's my network. Keep it in bed. Human data. Mhm.